Hello everyone, my name is Zainab Zahid. I'm an engineer at Meta, and today we are going to be diving into the Lambda service that powers all of the videos at Meta. Very specifically, we are going to be doing a case study on New Year's Eve. Now, New Year's Eve is the biggest day of the year for videos at Meta. Why is that? Well, let's think about what we're doing on December 31st. We're waiting for the fireworks to go off. And when that midnight strikes, we're going to pull out our phones, we're going to record those pretty fireworks, and maybe we're going to post an Instagram story, or maybe we're going to send that video over on Messenger, right? Now, let's kind of take a step back and think about that Lambda service that's powering all these videos. What does that look like? Now, on a regular day, we are executing billions of requests anyway. Now, you put in New Year's Eve and you put in that midnight, we're going to see a massive spike of traffic. The fun thing about this is every time zone is going to hit midnight at a different hour. So we're going to have an entire day of like pretty solidly spiky traffic. Now, it's not just the volume of the traffic that makes this a fun problem to solve and to talk about. It is the complexity and the diversity of all that traffic that we're serving on the same cluster and on the same tier. So you have a lot of use cases that are going to see a massive traffic spike that are co-located with use cases that are going to hold steady, right? Like if we think about ads are not going to spike with the fireworks, but your uploads are probably going to spike with the fireworks. We're also going to have use cases that are maybe very resource intensive. They're going to be very heavy use cases versus like very lightweight use cases. So our mission on New Year's Eve, our goal on New Year's Eve is to make sure that we are still giving the same customer experience and quality that everyone is used to. So very concretely, we're going to be looking at our reliability. We're going to be looking at our latency commitments, our latency requirements that customers have asked us for. And we're going to be looking at our compute. We are going to be looking at the efficiency and the utilization and throughput of our service and seeing that things are good. And of course, not to forget the engineers. We want to make sure that the engineers at Meta also have a nice day on New Year's Eve and nothing dies. So that's really the heart of this talk. I want to take a very holistic approach to talking about like, hey, what really shines about our system on New Year's Eve? So I am going to be diving into system heavy design concepts of how do we design the system? What's really going to be helping us out and be critical to our success? So I'll talk about things like the queue and, how are we actually managing the ordering of our requests and why is that so special? I'm going to be talking about quotas. So how are we being smart about the resources we're using? How are we doing memoization and protecting ourselves? But like I said, I want to be holistic. I do also want to talk about the operational side of things. So this is testing. We can never just kind of write code and assume life is going to be okay. We need to actually test it and we need to make sure it's going to be okay. All right, so before we dive into it, I do want to start off with walking through the request lifecycle at a very high level, what's going on when you upload that video to Fireworks. Okay, so Uma is going to go ahead and let's say we're getting a transcoding request. We want to generate an HD encoding for that Fireworks video that you just uploaded. We're going to go ahead and get that request at the API level. It's a declarative API. You're just telling us you want some transcoding done. We're going to go ahead and take that request. We'll hit two data stores. The first one is we're going to hit a queue. So again, a queue is really going to help us manage the order of requests that we're processing. And then the second data store that we're going to go ahead and store this request in is, you can imagine, just a key value store. We want to be able to make sure that we are tracking the life cycle of this request. So this is our state tracking. Now, finally, when our resources are freeing up, our scheduler is going to be pulling off work from that queue and processing it. When all of that transcoding is done, we'll go ahead and send that request all the way back up. This is going to be an asynchronous callback. And that is a super high level request lifecycle. Okay. Now I want us to remember this diagram as much as possible. I will be talking about it a ton. And I will also bring it back a ton and kind of point at it many times. Okay, so the first part we're going to dive into is the queue. Like I mentioned, the queue is that little pink box in the middle. We're using this queue to make sure that we are ordering our requests. Now, this is really, really critical in NYE because it decides who are we going to be prioritizing and how. Okay, so the queue is going to strongly pull in the requirements from what the customer is giving us. So very concretely, the customer is giving us a client ID. So we can think about this as an integer enum. You know, they're telling us who are they, who's he on call. It's a very operational side of it. It's really critical. If something goes wrong, we need to know who to talk to. But more than that, the client ID will actually play a very special role. And we'll dive into that a little bit later. So we have our client ID, then we have our latency requirements. This is the customer telling us that, hey, this request is urgent. Like, you need to execute it ASAP. There's a user blocked on it. Or they might be like, hey, this request is optional. Like, it's really nice to have. If you have resources, I'll be happy if you execute it, right? So you have an entire spectrum. And then finally, the customer is also telling us the priority of the request. So we have a latency bucket, and then the customer is telling us that, hey, within this latency bucket, here's the priority of the request. So they're going to very concretely give us an integer that we're looking at. Okay, now, why is this important for the queue? Okay, so the first thing we're going to do, I mentioned client ID, super important. First thing we're going to do is each client ID is going to have its own topic when it comes to the queue. Some use cases are going to be very stable. They're not really going to see much more extra traffic because it's New Year's Eve. When we have a topic per client ID and we're doing round-robin DQs, that means your big guy, so in this case, our client ID A, can't really starve the little guys. So we are going to be making sure that we are DQing work from everyone. Okay, so we've taken care of client ID. The next thing we're going to look at is the latency requirements and the priority. And how are they so critical? So we're going to go ahead and use the latency requirements and priority to order the items within our queue. So here we're saying, hey, the urgent requests, they're going to be at the first thing that we're DQing. And then within this latency category, this latency bucket of urgent requests, we're going to use the priorities that the customers are giving us and ordering the items within. Now, again, going back to the big picture, why is this important for New Year's Eve? I'm going to be asking that a lot. Why is this important for New Year's Eve? So once we're able to put together that latency requirement and that priority, we're able to be really smart about when we execute things. So we are able to time shift the compute to happen later if it's not necessary, right? So you imagine that spike of traffic coming in at midnight, you have a lot of urgent requests coming in, because imagine you have a lot of uploads coming in. A lot of users are waiting for their videos to go through. What are we going to do? We have the latency requirement, we have the priorities. We can go ahead and prioritize everything that's urgent and everything that's deferrable, everything that's optional, everything that's low priority. We're going to move it. We're going to delay it. We're going to wait until we have enough resources available, and we'll go ahead and execute that later. So that helps us be really smart about how we're managing our resources. All right, finally, we are going to be talking about one more thing when it comes to the queue, and I promise we can move on. The other thing that the queue is going to help us with is maintaining the reliability, okay? So New Year's Eve, what is the worst case scenario? The worst case scenario is you weren't ready for the spike and you got overloaded. Okay, that's the worst case scenario. So how does our queue step into it? We are able to monitor that, hey, this use case, traffic's not doing so well. We're seeing a whole bunch of failures. So now we're able to monitor the errors. We're able to kind of deduce if things are overloaded, if they need to be retried, if perhaps the errors are retriable, and we're able to put things back into the queue until we feel like things are recovering, okay? So the queue helps us retry, and it helps us delay and protect our downstream services if we think they might be getting overloaded, okay? So that's it for the queue. I feel like we have a pretty solid idea of where it's stepping in and why it's important and why. Now I'm gonna switch over and talk about quotas, okay? So going back to our favorite diagram of the day, we're going to be looking at the scheduler piece. So again, I mentioned the scheduler is going to be dequeuing work from the queue as soon as its resources are freeing up. So as soon as it thinks, hey, I have something I can execute, it'll go ahead and pull off a request. Now, the first thing it's going to do when it pulls off the request is, hey, do I have resources to actually run this guy? Do I have resources to actually execute? Right? Now, yes, you could be, and that case is really not that interesting to talk about. So we're going to talk about the scenario where you don't have extra resources, right? Because remember, we said some of the use cases that we serve are really CPU intensive and some are not. Now imagine that CPU intensive use case spiked 10x on New Year's Eve. It's going to want a lot of resources, and others are going to be like, hey, we're good. We're matching our quota. We're not using too much of it. But this guy is going to go over its quota. So that's like the more interesting case. So what do we do? All right. So the first thing we're going to do is we're going to look at all these other neighbors that we have in our cluster. And we're going to be like, hey, do you have quota? Can I borrow some? You seem to be doing okay. Now let's say no one else has quota. Okay. Everyone's spiked. Everyone has used their quota as much as possible. Like, what are we going to do? We're going to go ahead and we're going to look at how important is this request. Again, let's remember we have our latency category and we have our priority to kind of make that decision. So let's say we have an urgent request. What are we going to do? We really need to run this request. That's our SLA. It needs to execute right away. The second option we're going to consider is preemption. Is there something less important that's running on the queue? Is there something that is not an urgent request? Okay, so that's where quotas are going to step in onto NYE. Is A, it's going to protect the little guys that are not using that much, that are like being very good citizens. And then it's also going to help us be friendly neighbors, and we're going to be able to help others that might be needing more resources than we have. Alrighty, the last bit thing we're going to dive into on the system side, and then I'll go into the testing and the operation side of New Year's Eve. So we're going to be talking about memoization. For this part of the concept, I want us to think about that state store that we talked about. So here I mentioned a request is coming in. We're going to be storing state about it. So for instance, hey, where is this request actually in the stack right now? Is it in the queue? Is it being executed? Has it been failing a lot? Are we on like the fourth retry for this request? If that makes sense, that's a lot of retries. So that's what the state store is. Now, this is where deduplication and memoization kicks in, right? So when we're dequeuing that request, before we're doing the quotas check, we're going to say, hey, have I seen you before? Do I already have the response that you're looking for? Maybe I just generated that transcode, that HD encoding that you were looking for. If we have it, we're going to return it to you. We're not going to be running duplicate work. Now, this one is really easy to follow, but it might not be intuitive. Why is this important on New Year's Eve? I want us to think about viral videos. I want us to think about videos becoming really popular at New Year's Eve, right? So at Meta, we have frameworks that we're going to call them view time frameworks, which are basically going to be monitoring videos in real time, and they're going to be looking at the watch time. And they're going to say, hey, this video is getting really popular. It's getting a lot of watch time. I want to go ahead and start making sure I have high quality lanes. So I'm going to kick off more transcoding requests. So when you put all of this together and you look at the lower level of the stack, which is where the Lambda service sits, that actually does result in duplicate requests. On New Year's Eve especially, we cannot be wasting resources running duplicate requests. So this guy right here, this state tracking, is really going to help protect us. Okay, now we're going to go into the operational side of things. Okay, now as I mentioned, just because we've written the code, we really can't assume it's going to work. So what are we going to do? We are going to test in production, okay? As crazy as that might sound, what we've learned over the years is it's really hard to put up a staging stack or a test stack that is truly the same as production. It's really easy to miss a config. It's really easy to, it's really hard to not be able to have the same capacity on your test or your staging stack. And in a lot of these times, like in this case especially, we want to be testing the scale. How are we going to do at that 10x spike, for example? So that scale and being able to replicate that in a staging stack is pretty hard to do. It's pretty expensive to do because you need capacity to do that. So what we're going to do is we're going to test in production. We're going to be very careful about it. We're going to have checks and balances in place. Our entire stack is going to know end to end that, hey, this request, that's a production request, but this request, that's a test request. If anything goes wrong, I know which request to drop and just completely shed that traffic. So we're going to be safe about it, but we're going to test in production. We want to know that production is actually ready for New Year's Eve. Okay, so very concretely, what we're going to do is we're going to generate test traffic. And we're going to go ahead and add that on to our production tier. We're going to add enough traffic so that we are hitting our NYE expected QPS load. And we're going to hold it. We're going to hold it for 15 to 30 minutes. Now, of course, when we're uploading fireworks, we don't actually do that for 15 to 30 minutes straight. But for our load test, we do want to test the worst case scenario. Worst case scenario is you hit your NYE spike right away, and then you just held it. Like, people were really excited. They just kept uploading those fireworks. Okay. Um, and while we're at that peak and we're holding it for 15 to 30 minutes, we are going to be monitoring all the metrics that I mentioned earlier. So we are going to be monitoring what's the reliability at, what's the utilization of our pool? Are we being efficient about this? We are also going to be, of course, looking at the latency, right? We are replicating production traffic. So we have a very good assortment of urgent requests, deferrable requests, and optional requests. Are we doing the right thing? And then finally, I really like this diagram, so I have it one more time. But that pink box right there is our shadow framework. That's what I want to think about. We have a test framework that is sending test traffic through the exact same stack that IG is using or that Facebook is using. Again, the stack knows when it has a production request or a test request. And that's how we're protecting our customers while we test the stack, and we can shut it whenever. All right, that concludes us. So we talked about a ton of things, but I'm going to distill it down to just 2 takeaways. All right. So the first takeaway is expect the unexpected and be resilient. It sounds really generic, but it really reflects all of these design concepts that we've talked about. So, for example, let's go back and think about memoization. In the perfect world, we shouldn't be getting duplicate requests. Why are we getting duplicate requests? What's going on? It doesn't matter. We're going to be ready for it. Let's kind of step back and think other than New Year's Eve. We're going to have other special days where videos are going to be critical to our users' experience. Okay, let's think about Lunar New Year. Let's think about the next World Cup or the next Super Bowl. These traffic spikes, we want to be ready for it. More importantly, we want to be ready for getting more traffic than we thought we would. How are we going to be resilient to that? And more importantly, to that second learning, how are we going to test and make sure that we are ready for that? And how are we going to see that in practice, that we are ready for it end to end? So the second learning that I hope we go away with is we're not too afraid to test in production. So 100%, we want to be careful. Our customers are P0. Their user experience is P0, but it's possible and really valuable to be testing in production. And that's about it. There you have it. So the next time you guys are uploading your fireworks on New Year's Eve, you know what's going on in the background.